The equatorial rainforest, the lungs of planet Earth, an infinite horizon of trees and waters, a poem of biodiversity, a blessed land for all those interested in the mysteries of evolution. Stuart McCamey is a USDA World Authority on Treehoppers. Today, he is leading a team of 6 world experts deep into the Ecuadorian jungle to study these mysterious animals. Carolina Godoy from Costa Rica is an entomologist and author of the only scientific field guide on treehoppers. Nick Tatarnik is an evolutionary biologist from Canada. Patrick Landman is the French expedition photographer. Rex Cockcroft from the University of Missouri, Columbia, is specialized in the communication of treehoppers. Joining them is Yves Paquelet, philosopher and writer who has traveled the world with Captain Cousteau. The team is under the watchful eye of Umberto, their guide from the local Guarani tribe. They are working in the heart of the National Park of Yasuni, classified a biosphere reserve by UNESCO. It is roughly 180 miles east of Quito, the capital of Ecuador. To survive 40 million years from generation to generation, treehoppers have developed highly efficient strategies: camouflage, mimicry, but equally as important, community life, alliances with other species, and communication.
There have been lots of species that have probably evolved and gone extinct that we'll never have a chance to do, but by investigating this, which is a pretty large group of insects that are under our noses without us even knowing it usually, it helps complete the picture of what's going on in our world and how these ecosystems work.
This entire colony, it would seem, is being invaded by ants. Reality couldn't be more different. The young nymph treehoppers have no claws, poison, or defenses, and their wings are not fully developed to fly, to escape from danger. To stay alive in this hostile environment, many treehoppers have teamed up with other insects, a strategic evolution that has paid off. And their most sacred allies are ants.
What's actually happening here is what we call mutualism. The ants have not launched an all-out attack on these treehoppers, but they're looking for food. And strange as it may sound, these treehoppers produce a poop that the ants find simply delicious. It's highly rich in sugars and nutrients, and the ants just can't get enough of it.
Strategy of alliance number 1: food in exchange for protection. Treehoppers spend much of their lives feeding on the sap of their host plants, the result of which produces a tasty, sweet honeydew, and that is the treasure the ants will fight for. It's a sticky compound of water-soluble carbohydrates, amino acids, amines, organic acids, alcohol, oxins, and salts. The excrement is a great source of food for the nearby ants, and it's permanently available. The ants don't want to lose a drop and employ their antennae to stimulate the treehopper's abdomen, a kind of massage that seems to trigger the release of the Membrosidae's honeydew. Here, the treehopper plays the role similar to that of the milking cow, and the ant, the dairy farmer. Stuart has discovered that the Azteca ants have gone to a lot of trouble to build an enclosure around this plant's stem. Made up of small pieces of soil, Stuart believes that it is to stop their cattle from escaping.
It's amazing how much effort these Aztec ants have gone to build a casing around the plant to imprison these treehoppers. It guarantees them a source of honeydew, and the treehoppers still get to feed. And they might get some protection, but it's probably mostly at the mercy of the ants.
Protection, precisely what the vulnerable little treehopper needs most. Mutual ants will protect the eggs, nymphs, and adult treehoppers from any potential predators that might choose to attack. After all, it is a larder that is well worth defending. But young nymphs are delicious prey to this hungry reduvidae, looking for an opportunity to strike. Just a few centimeters beneath her is a quiet nest of Horiola treehoppers. An attack on the nest has alerted the soldier ants. They have taken assault on the invader. To save his life, the reduvidae is forced to flee. And the Horiola go unharmed. The army of ants on permanent patrol is a considerable advantage. The female Bobonota treehopper knows this all too well, for she will abandon her nursery, leaving the ants to tend to her eggs and nymphs. A winning strategy of evolution is in the making of alliances, a service in exchange for a service. I'll feed you, you'll protect me. But there are other opportunities. Communication is one of the more subtle solutions. If we can understand each other, we can help each other. Rex Cocroft has been studying the language of treehoppers for the past 15 years, making him the world authority on the subject. The team has accomplished the capture of 3 heteronotus treehoppers. They are solitary, and such a catch is extremely rare. Not unlike the fictional Dr. Dolittle, Rex is tapping into their secret language.
It's somewhere between breaking a code and learning a new language.
This is the very first time that anyone has tuned into the sounds of these heteronotus.
Wow, it's a fantastic sound. Nobody's ever heard that sound. You can be sure of that. There's a whole forest full of insects that are signaling using incredible sounds that nobody's heard. And people used to think of treehoppers as pretty, but kind of boring. And when you listen into their vibrational world, you realize that they're extremely communicative. They're monitoring their environment. They're communicating with each other with incredible signals.
Strategy of alliance number 2, communication. Just how treetoppers are reading these signals remains a mystery. The microscanner reveals for the very first time the magical, secret beauty of this heteronotus. An inside view of their pronotum structure reveals that it is totally hollow. Researchers know that the abdomen is their communicative tongue, but they are unaware if the pronotum could be in any way used to detect other treehoppers' vibrations. Rex's research has revealed that the treehoppers are speaking to each other by vibrating the plant's tissue. Their hairy legs are hypersensitive, enabling them to receive various signals, and they are permanently on patrol. Their feet are equipped with claws that rip into the host plant, ensuring close contact.
You can see, look around us, the plants dominate our environment, and there are sounds of insects and of some other creatures too traveling through them all the time, and we're completely unaware of them. So it's a completely undiscovered world out there.
Revealing undiscovered dimensions of the natural world is the duty of the biologist, constantly on the lookout to widen our horizons. It takes a 6-hour boat ride down the Rio Tiputini to the neighboring research station.
We already know there are at least 3,000 treehoppers in the world, and a rough guess, which is all we can do, is 10,000, which would be more treehoppers than there are mammals in the world.
And that might sound surprising, but when you think of all insects in the world, if you took all of them and put them on a scale and weighed them, they weigh more than all other living things. So to have 10,000 species of treehopper isn't a stat, you know, it's pretty realistic.
The river is particularly low, and Umberto, the local Guarani guide, has asked his son Ramon to keep an eye out for logs and tree trunks on the waterline. It's not a place to tip the boat, as the whole area is swarming with caimans and anacondas. There's one main reason that highly motivated Stuart to risk traveling down the Tiputini River. Stuart McCamey wants to find out if the Ant Treehopper Alliance is found at the higher levels of the canopy.
Yep. Lots of treehoppers up here. And lots there. Yep. Oh, there's a mixture of species here.
What do you have?
Aureola, is this it? Late in the story, mature, and 10 more ants biting my hands.
Horiola and ants is a familiar alliance that Stuart has already found at ground level. But high up in the canopy, there are more ants, and there is a reason for this. The treehopper's honeydew is the ant's primary source of energy. From the top of this ancient tree, the philosopher is asking himself, who does this forest belong to?
I can imagine being a tiny little treehopper. I wouldn't be able to see the immensity of the forest around me. I could even believe that it belongs to me. I would be unaware that other creatures called humans are threatening it, destroying it. I'm just a small member of biodiversity. I'm just a tiny little treehopper, but I am just as important as any other species on Earth.
Umberto, the native Guarani guide of the Amazon, is worried, and he should be. The team cannot return under the intense rainstorm, and daylight is running short. There were many risks at stake just getting here. 6 hours downstream and in daylight. Now the team is faced with navigating upstream after a large rainstorm and at night.
It feels like we're in a science fiction movie, in the lost world of Conan Doyle, searching for the last dinosaurs. But the last dinosaurs are tiny little treehoppers.
We didn't even know if we were going to make it, but luckily Umberto decided to push through, and we gave him some headlights, and now we're back home and ready to hopefully eat some dinner and look at our tree hoppers and then go to bed.
I really don't know if treehoppers dream. We don't know if insects dream. Yet another mystery.
Mystère.
The overwhelming heat and insects of the rainforest are not easygoing on the human organism. And while the team was away, Professor Carolina Godoy has fallen sick. Her legs have badly swollen and she is totally exhausted. She's off to visit the local doctor.
You'll be in good hands down there.
Okay, thank you.
Well, that's one down.
Yeah, hopefully there won't be any more.
Deep beneath the rainforest, Umberto is now guiding Rex Cocroft, who wants to record some treehopper sounds in their natural environment. The foghorn sound is produced by the wings of the Umbonia species, warning her fellow treehoppers that these two humans could be a threat. Strategy of Alliance number 3, have an alert signal.
Umberto was explaining to me how the Waorani use these trees to communicate. This is a tree they use like their radio. So if he's been hunting and has caught an animal, he'll bring it to the tree, then thump on the tree to call the family, and then they'll bring things to cook and have a meal right here under the tree. It's really interesting to see how these parallels between how the Waorani use plants to communicate and how the treehoppers that we've been talking about also use plants to communicate. They might also announce we've got food or we're coming to visit.
Ants are not the only insects to visit treehoppers. Bees, so it would seem, capture the vibrations of the Membrasidae. They definitely seem to benefit from collecting the honeydew from the young nymphs of this Atalian family. But scientists are unaware if the bees give any protection in exchange. On some branches, mothers can be found to brood in large numbers. It is the case here with the Metcalfiella species. Scientists believe that an egg-laying female produces pheromones that will attract other females, enticing them to lay their egg cluster nearby. Strategy of Alliance number 4, united we stand. But the jungle is also the kingdom of perfect selfishness. This tiny parasitic wasp is worse than a cuckoo bird, for he will do anything to strike an egg, laying his own egg inside that of the treehoppers. The chances of the treehopper's egg surviving such an attack are close to 0. The infected eggs will turn a yellowish-brown color, and the larvae of the wasp will feed from the egg before growing adult.
Oh, una ninfa.
Oh, a nymph! There's nymphs over here.
Regresé al doctor un poco más tranquila porque él dice que eso es parte reacción alérgica a la inflamación.
I'm relaxed after seeing the doctor because he told me that the inflammation in my feet and legs was an allergic reaction to chigger bites.
Yo estaba esperando que me comiera una
I was expecting an anaconda or a crocodile to eat me up, but it's the mosquitoes and mites that got me. Oh well, that's the Amazon.
Ay, bueno, así es la Amazonas.
Carolina has learned that the Amazon is a world of mystery and dangers. Researchers have discovered that many treehoppers have developed a subsocial behavior that is extremely rare in the insect kingdom. Numerous species will guard their eggs until they hatch and care for their young ones throughout the various stages of their lives until they turn adult and are capable of taking care of themselves. One of these young Achinophorini nymphs is ready for its final metamorphosis. And it's still under the watchful eye of the ants. We ignore which animal, if any, will make its meal of this Achinophorene's exoskeleton. Strangely, adult treehoppers do not seem to hop, but have an extraordinary capacity to both jump like a flea and fly like a mosquito. They use their wings with immediate takeoff and leave in search of a partner of the opposite sex. After several weeks of leading a solitary life, the young adults have one obsession: reproduction. But just how do they find each other?
It's a big forest out there, and there are a lot of plants and a lot of places to search. Probably they first find the right plant, because many of these treehoppers specialize on one or a few kinds of plants, and then they use their vibrations.
Strategy of alliance number 5: sing and sing loud to find a partner. Rex has synchronized his equipment with our camera. You are about to hear, for the very first time, the bewildering mating call of the Umbonia treehopper. These two males are calling out for the female. And she's answering from above. This male has localized her call. For discretion, we've turned down the lights. These romantic love calls would have gone unheard without the research, perseverance, and highly sophisticated technology of our scientific communities. Rex cannot pretend he is a male treehopper seeking a partner, but he can play the role of a dangerous Amazonian predator, and the scientific expedition team is simply amazed by his revelations. He has collected a mother Umbonia and her nymphs on a branch. The courageous mother will defend her vulnerable offspring against any predators, including Rex's paintbrush. Rex has amplified their signals using his dad's old phonograph cartridge and 2 accelerometers, which are basically tiny little contact microphones.
I'm going to get the nymphs to call.
Are these the wings that we do?
That's her using her wings. She's not taking off. She's not actually flying, but she's using those powerful wing muscles to create an incredibly loud vibration that can potentially drive away the predator and can also communicate very strongly to the young.
They don't hear the vibrations in the sense of human beings.
They don't. And the amazing thing is, if you were just stand next to this and we were not listening to the vibrations, you might see a little motion, but you'd think really nothing's happening. You wouldn't hear anything. There is no airborne sound associated with this at all.
It takes a little more than a wing flap to scare Rex. He's coming back, and this time the mother is going to stand up to him using a surprise kick that sweeps under the abdomen with terrific force. Let's see that again in slow motion.
They're pretty defenseless animals. They have to get right up next to the predator, and you saw what she did. She kicked, right? A tiny animal like this is defending her brood by kicking. And she buzzed her wings a bit, but she's got to be extremely close.
Strategy of Alliance number 6, have a loud defense system. It's 7 a.m. and already a humid 85 degrees Fahrenheit. The expedition at Yasuni is over, and it's time to say goodbye. But before returning home, the team wants to listen out for treehoppers in a radically different environment. After the rainforest, they follow the pipeline west. They will spend the last few days at the Bella Vista's Scientific Research Station, altitude 7,500 feet. This is the cloud forest. Despite the luxurious vegetation, treehoppers are harder to come by.
It's a tougher environment for the plants and the animals, including the treehoppers. And there are huge temperature fluctuations. It's like winter at night, and then it becomes like summer in the midday with the equatorial sun beaming down on them. We have to dress in layers, but the treehoppers can't do that. And there's virtually no overlap between what's here and what we found at Yasuni, down at the low elevation.
At this altitude, oxygen is short, and each step requires that extra effort. We've walked for quite a while on this narrow path. It's pretty steep, and we haven't found anything. Possibly because the path is a bit dark. A better place to find membracids is in open areas where there's a little more sun. So it's a shame because it's a beautiful path, but we haven't found any treehoppers. Rex has walked a fair way from the research station to a brighter zone. He cannot see as many treehoppers as in the Amazonian rainforest, but he can hear many vibrations. And where there are vibrations, there is life.
And this whole field is just a carpet of sound. There's something of a cocktail party effect here where there's can be a cacophony of voices out there, but if you're trying to pick out a particular sound, you're going to have to filter out all the others. So for a treehopper that's trying to listen for another treehopper of their own species, they're going to have to filter that out against a background of the sounds of many other species.
A mobile lab is the answer to his problem, in order to isolate certain species from the noisy grass.
We've got a male Metcalfiella, female Metcalfiella. The toucan, any airborne sounds get picked up by the leaves and are transmitted through the plants. So as you're walking past a tree full of treehoppers and talking, they can actually hear you even though you can't hear them.
Hadn't thought of it that way.
The level of communication between individuals is often associated with their level of socialization. Female Metcalfiellas are extremely maternal, and this comes as quite a surprise in the insect world. They are often found grouped together on the same branch, each mother laying approximately 70 eggs. As the team has already observed, the mother watches over her offspring and her nymphs with determination. But here, the scientists have noticed that the mother has a strange behavior. In waiting for her eggs to hatch, she will drill holes into the plant's stem in order for her offspring to feed more easily. These are one of the few treehoppers that are pests to humans, as these punctures scar and damage coffee, cocoa, and avocado plants. In the cloud forest without their ant protectors, the Metcalfiella are more vulnerable and must quickly grow into adults. This may explain why their mother punctures the plant stem. Strategy of alliance number 7, collectively adapt to the dwelling.
There are not very many ants up here, whereas the Amazon is teeming with ants. So we find here many species that have lifestyles in which the female lays her eggs and then in many cases will spend the rest of her life looking after that clutch of offspring. And by the time they're ready to fly away and start their own families, she dies.
Stuart McCamey has set up a light trap in the hope to attract some treehoppers.
We often don't get sheets that look like this, but when we do, it's usually good news. But it's kind of disappointing from a treehopper point of view because there are none.
It's a nightmare trying to find the treehoppers at 7,500 feet. But if Stuart cannot see them, Rex can hear them. But just what are they talking about?
These social signals that go back and forth between mother and offspring or members of a group tend to be very short, instantly recognizable, and very functional. Help, or here's food. But to attract a mate, you've got to do more than that.
Rex has not been able to record any mating calls at 7,500 feet altitude. He shares some of his favorite recordings.
That's hilarious. It's like a balloon. You're holding the balloon going. Was that a mating call?
It was. All of these are mating songs
Okay.
produced by males. Here's number 2.
Wow.
People wouldn't think of insect songs as beautiful, but I think you could use
It's like
that
whale
term.
music almost.
It is.
So is that a single individual doing that? Or
No,
is that...
that's a little chorus of males all singing together.
Oh.
We'll go from sublime to ridiculous.
That is ridiculous.
Here's one you'd never guess it's an insect.
It sounds more like a bird or a frog.
This one's a little bit longer, but hang on there. There's a real punchline at the end.
Wow. Aliens have landed. That's incredible.
Disappointed with their findings in the cloud forest, the team is checking out the outskirts of the town of Mindo. This is a future housing estate.
We're now at 1,328 meters, about 1,000 meters below the cloud forest. This place looks great. Let's spread out. All right.
Rex has come across a colossal community. By dropping 3,200 feet in altitude, the ants are back. And so is the profitable Treehopper Ant Alliance. Just like in the Amazon, ants have built a casing around the plant to keep a close eye on these nymphs and adult anti-ante treehoppers. Ants communicate using odors known as pheromones. Could it be at all feasible that they share a language with treehoppers?
It's going to be really hard to record from here because the ants are so protective. A very recent study showed that treehoppers can actually communicate with ants. When mothers of this treehopper are defending their young against a predator, the mother produces a series of little signals, and if you play back those signals to ants, the ants respond and approach and can then find the predator and evict it from the plant.
Strategy of Alliance number 8, communicate with other species.
We have learned that Darwin's theory on evolution is largely misunderstood. It is not the great battle where the meanest eats the others. Evolution is also strategic. Treehoppers show that you can be small, cunning, and you can integrate the biosphere. That the law of the jungle is not the law of the jungle. The law of the jungle is the law of community. It's the law of association.
With this kind of science, you don't know what's at the other end. You know, we might find something incredible from treehoppers that we can apply to humanity, we might not. But every single bit of knowledge that we learn about any living thing is valid in its own right.
Back home in Washington, D.C., Stuart's goal is to identify his catch from the Amazon.
This trip was more successful than I could have imagined. I've never, in my years and years of collecting, I've never found such a rich fauna, so many species, so many genera in one place.
If most species can be identified under a microscope, this technique has its limits.
So even under the microscope, many species of treehoppers look very much alike. So you have to use other methods to differentiate them. Study their DNA.
And Stuart's worldwide reputation has even earned him a species that carries his name.
Like in all areas of science, in a sense, the more we find, the less we know, because every discovery just brings up new questions. This is a treehopper 40 million years old, trapped in fossilized tree sap.
You can see its wing, and there's the broken off leg. Whoa. Looks so huge. It looks like it's in space. It's kind of cool.
Back at the University of Missouri-Columbia, Rex Cockcroft continues his quest to reveal new dimensions of the treehopper's world. Under the protection of this greenhouse, he is breeding Ambonia crassicornis for his research requirements, one of the 200 species that naturally occur in Northern America. Treehoppers communicate using the same frequencies as we do, but for us to hear them, their vibrations need to be amplified. These insects are at least as sensitive as our most sensitive equipment. Back in his laboratory, Rex is able to use a laser vibrometer.
And the technology is much like the police radar that a policeman would use to measure the velocity of your car.
Rex is going to play back his recordings via this apparatus that will transmit the audio sounds into a substrate vibration.
One of the great things about working with substrate vibrations is that we can play them back into the plant, and the insects will respond to our playbacks as if it was another insect.
Let's see how this male reacts to Rex's recordings of a calling female. At first, the male seems disorientated. But it doesn't take long for the male to mistake the playback apparatus for a courting female. Rex is mastering Treehopper's secret language. But how can this help humankind?
There are many situations in which people want to know where a vibration is coming from, whether it's an earthquake or whether it's a vibration in a car that somebody's designing. And I've been collaborating with some mechanical engineers for several years now in order to understand some of the tricks that treehoppers use to localize vibrations. And it turns out that the treehopper's body itself acts like a little directional sensor. It moves differently if the vibration comes from in front of it or behind it.
Strategy of Alliance number 9, interpret the vibrations of a predator.
I've looked at treehoppers across the family and found that communication is universal, and so they've probably also been communicating for the past 40 million years. And that may be part of why they've survived so long and been so successful.
Treehoppers have offered us an amazing array of forms and colors, like a dream on planet Earth. But scientists have taken our knowledge of their world one step further. These insects are exceptional beings of communication. They have their own language. They swap information within their own species, with other species, with the plants that support them, with the forest that nourishes them, and within the biosphere which we are also a part of. Everything is linked.